that is called as a this kind of scattered diagrams here giving the number of points we have. That number of points represented into the x-axis distances and y-axis distance. This kind of the total observations of these points is generally be denoted by the bracket of xi comma yi, I equal to 1 to so on. This is called as a scatter points. Scatter points. In this scatter diagram and scatter points, I am representing x and this is called as a bivariate distribution. Bivariate means it is involving there is a two plots of the x and y plots along the x-axis and the y-axis, so that it is called as xy plane. Here you can see that it is a xy plane in between here, so that it is called as a scatter diagram. Now, here I plotted that's a diagram. The scatter diagrams is a fairly good through the vague ideas of this is variables are the correct correlated and are not. There's the points at the very dense, it's very close to each other. We should expect that it's a fairly good amount of the correlation between the variables, and if it is the points of the brightly scattered and poor correlation is expected. Now this method is, however, it is suitable for the number of observations, the very large number of the points we can be checking it. Carl Pearson, what he observing that it is correlation coefficient is identified. Correlation coefficient is we can calculate by using that is a COV correlation of x comma y. Correlation of x comma y is we have one formula that is called as here 1 by n. Here we have a formula. Here covariance of x comma y is equal to x comma y equal to here 1 by n into summation xi minus x bar into yi minus y bar. Is a product of that. So we can take that is a kind of observations is called as this. So here this is called as a 1 by n of summation xi minus x bar into yi minus y bar. This is called as a product of covariance. Covariance means I will use this formula and I will find out there is a covariance of x comma y. That after finding these values for the given data is this xi yi will give. I will find out this is a value covariance of x and y. I will take in the numerator. The denominator is close to the here sigma x square. Sigma x square equal to 1 by n into summation xi minus x bar whole square. So here 1 by n into summation xi minus x bar whole square. I will identify that is called as a sigma x square. Now I will identify the sigma x square. Similarly, sigma y square also I will identify 1 by n into summation xi minus x bar whole square. After getting that is a formula is a covariance of x comma y, then it is called as a sigma x into sigma y. It's called as a rank of correlation, coefficient of correlation R of x comma y. So this is our required formula is given in between that. See here, it is called as a sigma x square equal to 1 by n into summation xi minus x bar whole square. Now it is a covariance of x comma y by sigma x into sigma y is our required formula. Now I am going for that is a sigma y square is also I can identify summation 1 by n into summation yi minus y bar whole square. Covariance is 1 by n into summation xi minus x bar and yi minus y bar. So covariance we can calculate by using this formula. The covariance formula I substituted here in the numerator part and denominator part also 1 by n into summation xi minus x bar whole square. 1 by n into summation yi minus y bar whole square. 1 by n into 1 by n square coming outside this 1 by n is will be the numerator and denominator, so that both will be the cancel. Because of root of 1 by n into root of 1 by n equal to 1 by n. And numerator is also 1 by n. 1 by n and 1 by n is cancelled. So R of x comma y equal to summation xi minus x bar into yi minus y bar by root of it is a xi minus x bar whole square into yi minus y bar whole square. Now I will be substituted here. It is a total simplification. I'm getting this one. Now it is a scatter diagram. It is a rank correlation. You are calculating the R coefficient of Carl Pearson he developed, so that it is called as Carl Pearson correlation coefficient we called. So that is R of x comma y is called as a correlation coefficient. That is a correlation coefficient is greater than 0. Here being like this is the diagram, and R is less than 0 being like this diagram, and R equal to 0 being like this R diagram. It is a R equal to 0. R is a plus 1, R is a minus 1. So here, this is observations for that. It is whether it is correlated strongly or it is strongly or not correlated or something else like that. We can say that it is whether it is correlated or not correlated. So relationship between these two are the Here R is greater than 1, it is correlated strongly. It is R less than 1, it is not correlated strongly. It is R equal to 1, it is correlated strongly. It is not correlated anything else. So this is our overall idea about it. It is a correlation of X comma Y. Limitations over the correlations is R of X comma Y equal to covariance of X comma Y by sigma X and sigma Y. So R of X comma Y is our required formula. Here just now we got it, and R of X comma Y simplification and R square is called as it is the formula. So that is a summation EI into summation Bj by, because of Xi minus X bar, I'm taking the A, so that YI into Bi whole square by summation EI whole square into summation Bi square. It is an inequality condition is fulfilled, so therefore it is called as a one and only one. It is A1 by A. P1 equal to A2 by B2 equal to so on AN by BN. This is a theoretically how it is a squidge inequality has developed, that it is less than or equal to. It means that it is a always it is a correlation coefficient is lies between the -1 and +1. That is developed by the Carl Pearson coefficient of correlation. Now, one thing is here correlation coefficient is independent of the changes of the origin and scale. So that R of X comma Y is we know that just now we did the formula of correlation of the X comma Y by it is a sum sigma X into sigma Y. Now here U equal to I'm taking X minus A by H and V equal to A Y minus B by K. So it is X equal to A plus HU and Y equal to B plus KV. It is a theoretical analysis. It is a expectation means first mean I am calculating and second expectation means second mean I am calculating. Next, it is called as first moment and second moment, whose product is a X minus E of X and Y minus E of X I am calculating. So that it is a previous values I substituted in the X values and H and E of U values. Then H I can taken the common, and below at our bottom also K is we have taken the common from the V. So correlation of covariance of X comma Y means E of X minus E of X into Y minus E of Y. So that it is a H into here U minus E of U, and here K into V minus E of V from above values. Then I am getting that these expectations values are called as HK is common and covariance of U comma V. Now sigma X square equal to expectation of X minus E of X whole square. So that simplification is E of H square into U minus E of U whole square. So H square into sigma U square. So that sigma U square is called as a covariance variance of this given data, that is called as along the x-axis. It is sigma X equal to H into sigma U. Next, similarly, I can calculate the variance of the sigma Y square is E minus expectation of the Y minus E of Y whole square. So it is a K square into V minus E of V. So that it is a K square into sigma V. These values I substituted, so that I am getting there is the same result. R of U comma V is equal to the R of X comma Y. Therefore, it is a correlation coefficient is a independent changes of origin and scale of the fundamental improvement in the numerical computation of the correlation coefficient. So that is called as our required definition of the here independent changes of the origin and scale. It is possible for that is a correlation coefficient. Correlation coefficient is always independent of the changes of origin and scale. So here it is a conversion to that. It is I'm getting that is R of U comma V, but is not will not change. Value will not change. This is the overall idea about it. Here expectations. Here examples I'm taking. Sometimes it may be the equal to 0, 2 independent, and it means that is no correlation we have. R equal to 0, it called as no correlation we have. So that here 2 examples I'm taking, that is it is a given data father and son. I'm taking the father, he will do that is some work, and son will do the same work only. But it is a father will be having the whether I want to check it is both father and son, both works are the correlated or not. Otherwise, do we have that is a variation? That is I want to identify. So it is a calculate the correlation coefficient. Correlation coefficient is a strongly agree or a disagree. I want to tell means it is depends on the R. So R equal to covariance of X comma Y divided by sigma X into sigma Y. I want to identify. Sigma X means the variance of X and then sigma Y is the variance of the Y. So here I'm calculating that it is a clearly we have a formula R of X comma Y equal to covariance of X comma Y by sigma X into sigma Y. That is called as a sigma xy by root of sigma x square into sigma y square. So x data I'm taking and y data I'm taking, x square I'm calculating, y square, xy also I'm taking. Total summation I'm calculating, I'm substituting in the formula. Summation xy by summation x square into summation y square. So here summation xy means already I got it, that is 37560 by root of 37028 into root of it is a 38132. So this is R equal to how much I got it is a 0.63. It is called as a positive correlation because of 0.5. More than 0.5 means it's a positive correlation only to the heights of it is X and Y. So it is there is a very strong, not strongly correlated. It is a we have that is either son or father can be do that is a both work. There is no any problem. Strongly correlated means it is a father and son both are the same work. It is both are the more efficient. That is only the one of the problem how we can be doing it. Once again, listen here. R is a formula you should write. Then it is a X data you should take for the first column, second data Y data, and product X square values you can calculate by the calculator, and Y square values you can calculate by the calculator, and X Y data we can calculate by the calculator. Then it is the ratios I can calculate. I will substitute in the formula of R of X cover Y equal to summation X Y by root of summation X square summation Y square. So I substitute, I got it the answer 0.63. Next, it is another example you can do it here. Here, a study of conducting another example. It is a 10 students investigating the association between the mathematics and statistics test. I conducted the statistics test, and the students are getting these are the marks. Whether it is both are the equal or not, I'm going to check in. So it is a testing of that. It's both are the agreed or disagree of whether it is a correlated or not correlated that I want to identify for the given data of the students of the mathematics and the statistics. So it denote that R of X comma Y equal to here summation Xi minus X bar into Yi minus Y bar by root of summation Xi minus X bar whole square into summation Yi minus Y bar whole square. So X bar equal to summation 1 by n into summation Xi and Y bar equal to so 1 by n into summation Yi, and n is the number of students is at 10. Because of your count is clearly here 1 to 10 will be there. So that is n equal to 10. Here X data you take into the first column. Y data you take into the second column. And I'm taking that is a total. It is Xi minus X bar. X bar is a Xi how sir X bar how I can be calculated is a total sum of the elements. So here how I can be calculated. You see here total sum of observation. Here summation Xi. Here bottom I will write it is a X bar equal to summation Xi by. So what are the values we have added? X1 plus X2 plus so on plus Xn. What are the values divided by how many we have 10? This is the X bar. So it is X bar is a we can substitute. Similarly, Y bar also. Y bar equal to how much mean value? Summation Yi by divided by n. So it is a here it is mean that is a Y1 plus Y2 plus so on plus Yn divided by 10. So this is called as X bar and Y bar. Now here we can go for that is a total data mathematics and statistics he has given source R of X comma Y equal to summation Xi minus X bar and Y minus Y bar. So root of summation Xi minus X bar whole square and summation Y minus Y bar whole square. Here Xi X bar equal to 1 by n into summation Xi Y bar equal to 1 by n into summation Y. N equal to number of students 10. So X and Y bar equal to here Xi minus X bar and Xi minus X bar whole square, Y minus Y bar and Y minus Y bar whole square. Next, you product it to both of them. Then it is clearly, we can get that is Xi minus X bar data is here 20 and 20. X bar, no, X bar equal to total is how much? 173 is a one total. It is X bar I calculate. X bar is clearly it is giving the sum number. Then its subtraction is going on the 2.7 from the X and Y is a 7.2. Then Xi minus X bar whole square I did immediately. And Yi minus Y bar, yeah, we calculate and do the squaring. Then Xi minus X bar and Yi minus Y bar we do it. And total simplification by calculator, if I do, I can get these are the results. Then these results will be substituted in the correlation formula. Your correlation formula is here. This is a summation Xi minus X bar into Yi minus Y bar. So here, if you substitute directly, you can get that our correlation coefficient R of X comma Y. Here R of X comma Y is at 228 by root of 358, 356 and root of 358. So that it is a difference of that rank is a correlation 0.71 by calculator. So that it is also positive correlation only, positive correlation. Sometimes here he will not give the data, just he will give that is a values he will give. Now, number of terms is how many you want to be identified. So I will substitute in the formula. It is a summation Xi minus X bar. Summation Xi minus X bar is he give that is a data is how many? It is a 120. Summation XY. So it is a 120 in the numerator. Now it is going for the summation xy square, sigma xi and sigma yi. So that it is clearly, if I calculate, it is an over 90 root of 90 into 64 n. Here, 8 square means it is 64. N is inside. Then it is a value is a r is a 0.5. So that it is a by cross multiplication, simplification, I can get that is n equal to 10. So this is called as a correlation, rank correlation. How we can be identified by the Carl Pearson. In this space is below to the writing of the answers. It is you can do these are the problems into the same procedure. Now correlation coefficient for the bivariate frequencies. Here correlation of the calculation of the correlation coefficient for the bivariate frequencies. It is when the data is considered the large. They may be the summarized by using there is a two-way table. Here they use the two-way table for the variables of the suitable number of the cases are classes are the taken. In that here same is considerable in the Euro rate case. If there are the 8 classes for the exact m cases of the y, there is a m by n cells will be there two ways table, so that from the two ways table it is a x is independent, y is a dependent. Based on that we can be identify that by bivariate data it is a x and y, so that it is a simplification we can take that as a two-way correlation coefficient. Summation x and y equal to here f of y, so that it is a sum of the frequencies along the any column is that we observe that it is a summation f of x comma y equal to summation f of x comma y, summation f of x and summation g of y equal to n. So whose product, if I calculate x bar and y bar, then we can calculate this kind of the table total frequency. And this is a table is goes to the bivariate distribution table, correlation coefficient for the bivariate frequency. Bivariate frequencies means it is a large data will we have. That large data point of view, I will calculate there is a mean. It is also the same procedure. And y bar also I can identify the same procedure. Now it is a sigma x square equal to this one. So that it is a midpoints and x series and y series and classes and midpoints and total frequencies we can identify the y into g of y, and g of y will be this total. This is f of x value and total frequencies I can identify total sum is the capital. So from this it is the age and frequencies of the marks and obtained by the young unpaid students and intellectual test. Now I am taking that as a ages and marks he has given. Now I want to identify that marks are the correlated to the ages or not. That is otherwise marks are the correlated to the ages or not, and ages are correlated to the marks or not. It is a total observations I want to identify for the different kind of the ages and different kind of the marks stages he has given, so that it is kind of the x and y planes. It is in between what kind of the correlation we have that I want to be checking it. So here correlation is it is clearly here 10 to 20 and 20 to 30 and 30 to 40, 40 to 50, 50 to 60, 70. I will take it here. Yeah, these are the called as the marks up to 70. Next year I am taking that as the ages are 80, 90, 20, 20. And so that these are the ages. Now correlation I am taking that is a center, you divide that 0, and after it is up is -1, -2, and bottom is 1, 2, 3. Then here also center is a 0 and left is -1, right is +1, 2. Now here 10 to 20, it is a frequencies already he gave. So here that is the data I'm giving, that is a in between this is a gaps. Now whichever is a addition we have to find out, that is the total sum of the values. Sum of the values means it's a total is a how much? Here total, here total, here total. U into what is a U? U into this is a U value. U is a -1 into this corresponding f of u, so that it is -19. Similarly, here also 0 into 22. So it is a 0. Here 1 into 31. So that 31. Here bottom is a 2 into 28. So 56. Now, this is one kind of the correlation. We have another correlation. We go for this. Now it is a correlation data. So I'm finding that is a f of u's and u into f of u's. And u square also we have that's a top only u square. U square, u value may have -1 means -1 whole square. 0 square, 1 square I will identify. Then I will substitute here summation uv values if I calculate. Here also summation uv I will calculate. All. Then after getting the results, since I am taking that is x minus 19 is a mu, y is a correlated, it is a u summation u v of f of x comma y I'm finding. So here data are available from the top x minus x square, and the covariance I'm calculating, and the sigma x square I'm calculating, and sigma v square I'm calculating. Then I'm substituting the r into u comma v equal to correlation of u comma v of sigma x at sigma y. So that 0.25. 0.25 it is a very less. So that is a correlation coefficient is independent changes of the origin and sales. So independent means it is a no way correlated. It's a almost it is a zero, so that it is no way correlated. It's a one is a data is independent to the other data. That's all. In this unit, it is exercises. Explain the concept of the correlation, define the correlation and Karl Pearson coefficient of correlation limits, and one problem on the correlation coefficient and the Karl Pearson here also coefficient correlation. Then here 10 students of the data he has given, find the coefficient of correlation. Here it is a multivariate correlations he has given. This is an oral idea about that. Do this. Here above examples of values he solved. So correlation of the data. Here also, here let u equal to x minus 82 into v equal to y minus 68. So that this is also rank of the x comma y equal to r of u comma v equal to n into summation uv minus summation u into summation v. The same formula and given data, the data I have substituted. I got it. That's a rank correlation. R equal to 0.78. It is a positive correlation. Here also, second one is also correlation coefficient is a we identify R of U covariance of the x comma y by sigma x and sigma y. It is called sigma of x minus x bar y minus y bar root of summation x minus x bar summation y minus y bar. So that I'm getting 0.9. Strongly correlated. Strongly correlated. These are the exercises and examples and the last questions. So if you prepare well, it is enough for that. Next, it is a rank correlation. Previous, it is a coefficient of correlation. It is a coefficient of correlation R equal to summation covariance of x comma y by sigma x and sigma y. Sigma x and sigma y, variance of x data and variance of the y data. Not variance, standard deviation. Because of root of variance is called as a standard. Sigma x into sigma y. We should use covariance of x comma y. So this is called as a rank correlation. Rank correlation. Next, I'm going for that is a coefficient of correlation is completed. Now I'm going for that is a rank correlation. Spearman, he identified that is a one more formula. It is called as a rank correlation. The rank correlation is a we will be used. That is a this kind of the formula. Here sigma equal to rho. Rho. This is a how we can be denoted. It is a rho. What is that? It is a rho. Rho means it is a correlation coefficient. This is also rank correlation is coefficient of correlation. So based on the rho, we can be decided. This formula is a 1 minus x sigma d square by n into n square minus 1. This is called as one of the formula. So here I can be taking this formula here and I will solve that problem. Yeah, see here rho equal to 1 minus x sigma d square by n into n square minus 1. N is the number of pairs we have, and d is di is the difference between the pair of the two ranks into the same individual to the two characteristics. Here also all the scattered data he will give, that is xi and yi. All scattered data are x1 y1 and x2 y2 and x3 y3 and x4 y4, so are xn yn. All individual end data will be have and two characteristics values. Two characteristics values. It is n individuals into the n two characteristics of A and B respectively into the gender. Individual will not be equally proficient into the both characteristics of X and the rank categories. It is a Xi all the ranks and Y ranks should be allowed, and a difference you should identify the ranks, and the summation D square you should identify, summation total you identify summation D square. N is the number of ranks he has given, number of ranks are number of ranks are. So that is a formula in that we will substitute that automatically we can get that 1 minus x sigma d square by n into n square minus 1. So that I can get that as the answer. This is a proof of that rank correlation. Rank correlation. A rank correlation is who developed means it is a Spearman rank. Spearman only developed. So that Spearman rank correlation is the name of that. Spearman rank correlation formula is a simply here 1 minus x sigma d square by n into n square minus 1 only. Now here it is a between the ranks of X comma Y is I am identified. One problem if you do, you can understand easily. Then after I will come for the proof. Yeah, see here, two judges in the beauty of the competition of the rank of the 12 entities as follows. So here x-axis, x data is a 1, 2, 3, so on up to 10, 12 ranks he has given. Ranks only mentioned, and here also Y also he mentioned the ranks. So here ranks only mentioned 12 ranks. Here the coefficient only mentioned. Otherwise, if you give the data, we will allot the rank. Already he gave the ranks, so no need to allot for the ranks. It is how we will allot the ranks. It is the smallest is the first, smallest is the first, highest is the last. Next is the 1 minus x sigma d square by n into n minus square minus. Here ranks first data, first x-axis data I am taking in the first column, first column, and second data, second column. You can see here. Next, the difference is R1 minus R2. So it is a difference is a 4 minus 1 minus 4, 2 minus 2 like that. It is a 4 minus like that. It is a next it is a whole square I'm doing. So minus 3 whole square, 0 square, minus 4 whole square like that. I'm getting this 121. Total is called as the summation d square equal to 191. These values I will substitute in the formula. Rank correlation is 0.31. So it is a positive correlation. It is a computational, it is a positive correlation. They have a very less positive correlation, not than a strongly correlated. It is small, it is the same data we can be followed. Question. Okay, anyway, today we discussed total concepts. I will wind up the session plus we will discuss about rank correlation. Okay. Hello, Nilokas. Hello, Nilofa. Hello. Yeah, today we discussed that it is a correlation. Correlation coefficient, how to find. It is the first unit I covered. Second unit I can cover that is a correlation I explained. Next class I will discuss the rank correlation. Thank you. I will wind up the session. Thank you.